Okay, so we're back, and we have our cylindrical picture here. But what I want you to do is pull up your line length code. Okay, that was how we made a line segment. I think I need to change my n value is set at 2 right now. Okay, and what is wrong? Oh, my maximum y needs to be a lot higher. Let me change this n value up to maybe 4. All right. And let me change, since we're going to go to 4, y max better be obviously 16 or bigger. Let's change that up to make that 20. And we can run the code and we can see our parabola, and we have the calculation for the length of the line in the title. Okay. Now remember, that's the length of the 4 segments using a Pythagorean theorem for each one, and they're then totaled up. So if I want to get the length of the curve y equals x squared from 0 to 5, oh, actually I'm going 0 to 5. So actually I better, b is 5. I better make y max bigger. Let's go to 30. Okay. That gives me a reasonable estimate of the line. If I want a better estimate, I would divide that, make that into more segments, like let's make 20 segments. Then the curve looks pretty smooth, and we can see we get a slight change in the line length, but not much. So the actual line length is something we must be approaching here. Remember, the segments always cut corners. So the actual line length is bigger than the answer that we have for 20 subintervals. If we increase that to 40, it doesn't change by much. Okay, so we're clearly approaching the correct value. So let's go back down to 4. All right. Now, one thing I don't like about the code that we left is the scales are very different. Okay, we're actually trying to see what the physical length of this line is. And the y scale goes from 0 to 30, and the x scale only goes 0 to 6. And so it gives us a skewed sense of how long the line is. So what I want to do is come down under my axis command, and we're going to add axis equal to that. And we're going to run this again. And you'll see that's actually a better representation of the shape of the line. Okay, so it's kind of scrunched in, and the scaling is now 1-to-1 between the x values and the y values. All right, so we're trying to measure this line by having it be drawing it in 4 segments. We can draw more segments and get a better value. Now, because that's skewed so far in the vertical direction, I want to turn around and divide that by 10. And you know what, for good measure, let's add +2. Okay, so this is now the segment that I want to work with. Okay, and the axes are equal. And you can see the window that I'm working with is way too big now. I probably want to keep x min, x max about the same, but y minimum could be -1. Y maximum could probably now be 5. Okay, and we can see what that line length looks like more clearly. So you should be coding along and making the changes in your code as I make them. If you haven't been doing that, go back to the beginning of the video and make the changes as I go. Now, we want to turn this line length into a surface area code. So probably before I do that, let me save as. And let's change this to surface area. And I'm going to call this 2 because I already wrote 1, but you don't need to put that 2 in there. And I'm going to save this. Okay, and now I've changed my title in the comment to surface area. Okay, so I'm going to draw a curve in the formula and rotate around. We'll just do the x-axis. X-axis. And calculate the surface area. Okay, so we're going to take the same line that we have, here, and we want to rotate that about the x-axis. So let's figure out how we're going to do that. Okay. There aren't too many things that we actually have to change. All right. The first set of things that we're going to change are the calculating the line length. Okay. We want to calculate the surface area. Right. Instead of cumulative line length, this will be cumulative surface area. All right, and we're going to start, instead of L, I'm going to have A. Now look at what happens. It allows me to shift enter and change all L's to A's at the same time. So you'll notice down on line 25, the L's that had been there are now A's. All right. Let's see, dx is going to be the same thing. dy will be the same thing as it was before. So we still have those little Pythagorean relationships. For each segment has a change in x and a change in y. Think about delta x and delta y. So dl was the hypotenuse of the triangle. We're still going to have that, but now we need to create a dA. Whoops, a dA. This is an area, the area of a single segment when rotated around. All right. And we learned in class that that would be 0.5 times. We could take the average, we want the average radial value. All right. So between one end, so let's say we're looking at the second piece here, there's a smaller radial value from the x-axis up to this point right here, and a slightly larger one from there to there. So the best value to use for the radius, okay, would be the average of those. All right. So we're going to have 0.5 times y of it, whoops, plus 1 plus y of it. Okay, so remember, y of it is the y value we're on. So if we're on the first time through the loop, y of it would be the leftmost point, and then we have the next point would be the other y value that we're going to average with it. So you can see they're close to each other, but we'll average them. And then for the second time through the loop, we'll start here and go over to here and so on and so forth. Okay, so that's our average radius. Oh, and then we're going to want to take 2 times pi times the average radius. This is the 2 pi r in the formula. Okay, and then we're going to need to multiply that times the dl value in order to get a little slice of area. Now in the cumulative area, instead of adding dl on, I will add on dA in line 26, right? So notice this formula, this is really 2 pi, and then this next part in here, that's averaging the y values at the two ends of a segment. So the y values are the radial values if I rotate around the x-axis. And then we're going to have times the length of the line segment right there, which is your DL. All right. So that's the calculation. Now, we're going to want the title to change. So let's go down to the title. We're not going to want the line length. We're going to want that to be surface area. Okay, and it's already changed num to string A instead of L. Okay, and we have the number of subintervals already printed. So this will change us to surface area. All right, and if we now what we're going to have to do is change what we do with the plotting, okay, in order to get this to work. Okay, this is where we need to use the cylindrical information that we had before. Okay, so and we're going to have to add some 3D effects to it as well. Okay, but let me start with getting rid of basically, well, most of this section, but not all of it. So let me get rid of, actually, let me just comment this out because we may bring some of these things back in. So you can add, make all of them a comment. You come up here in the editor, see where the mouse is, and hit the % sign, and those are all now comments. Okay. So under the plots, I first need to make the cylindrical values. So this is my remember we wanted to rotate around X. So we're going to do Y, Z, then X, so that it will rotate around X. Those are all capitals. Whoops. And I put those in brackets. Okay. So those values are going to be generated by taking the cylinder of, let's see, it's going to be the Y values. Because our curve, the Y values of the curve tell me what the radius of that will be. Okay. So that will produce the points around the edge of the cylinder. All right. But now we have a problem. It's only going to be 1 unit long in the X direction. We can see here, this cylinder, when we rotate this around, we want it to go from 0 out to 5, or actually from A to B, all right? So how do we do that? Well, first of all, we're going to need to make a constant. So I'm going to make this Q value just ones, okay? This is just going to represent a constant for adding, and it's going to be the size of X. So it's going to create Q values. Oh, and I should have a semicolon there and a semicolon on the line before. It's going to add, just have a matrix of ones that are exactly the same dimensions as those X values, right? Now I need to be able to stretch out my X values. So I'm going to let X be reassigned as the width of this is the B minus A. B minus A tells me how wide the interval is. In this case, A is 0, but the 5 minus the 0 tells me how wide, or how tall the cylinder will be that's going to be laying on its side, okay? And I'm going to multiply that times the X values, and then I'm going to add on to that. If A wasn't 0, I would need to shift them all over by A. So I'm going to do A times Q, and that would shift the cylinder over by A. So the first part of this forces the cylinder to be B minus A tall. That's how wide the interval is going to be. And then the second term of that slides it over by A. Okay, so let me put a comment on this. Okay, this will stretch cylinder from A to B. Okay, so that's what that line of code will do. This just creates a constant. Constant matrix of 1 that we can use so we can add it on to X. All right. Okay, and then from the previous video, we learned now that we can do a surface plot. Okay, so we'll do a surf of X, Y, whoops, X, I need commas there, comma, Y, comma, Z. Okay, so there's my surface plot, and we should see that rotate around. Okay, now coming down here before we plot, we'll want an X label, so I'll reinstate that. We do want a Y label, and now we're going to add a Z label as well, because this will be 3D Z label, and we will put in Z. Okay, so we've added a Z label. Let's see what else we want in here. Well, let's start with that and see what happens. And you can see we have a cylindrical plot, okay, that kind of, it follows what we were doing, okay. Now we can do some other things, like I can bring the axis equal command back in. Let's do that. And that gives you a more accurate depiction of what the shape would actually be. Okay, so that looks much nicer. It's a much more accurate depiction of the curve that we have. All right, let's do some other things in here. So what I do want to do before we move on, I want to add X, Y, and Z axes to the picture so you can see how this rotates around those axes, right? So in order to add axes, I have to make sure I don't, so we're going to add axes. Let's put a little comment, add axes. Okay, so I'm going to put on a hold so that I don't erase what was already drawn. All right, and I'm going to then I'll turn the hold off. And in between there, I want to plot my axes. Right, Now, this is a three-dimensional plot, so you have to do plot 3 command. That's something new. All right. And we want our, in order to plot the x-axis, all right, I have to give the x values first, okay, which will be the minimum. I'm going to plot from the minimum of x to the maximum of x. We're going to connect 2 points together. One is at the minimum x value and one is at the maximum x value. And notice I put that inside of of brackets. So that is 2 points of a vector. Okay. Now, what are the next thing I have to do is put in all the y values. Well, if I want the x-axis, the y values are 0 at both ends of that. Okay. And then we need to put in the z-axis or the z values for those points. And if it's the x-axis, those z values are also 0. All right, and I'm going to make that a black line. Okay, and I'm going to actually make it bold by putting in a command called line width. Whoops, I need to put this in apostrophe, like single quote. And width needs to be capitalized. Okay, I believe this will work. Let's see what happens when I run it. Okay, so we can see in there is an x-axis in the middle of all of that. If I rotate this around, I'm seeing the x-axis in the middle of it all. Right? Well, I also want to create a y and a z-axis. Okay, so in order to do that before the line width command, I'm going to add 3 dots. It means to keep going. And I'm going to copy the x-axis. Whoops. I'm going to copy everything that I had for the x-axis. Command C or Control C on your computer. Okay, so this would do the x-axis again. Okay. Now what I'm going to do is I want this to be the y-axis. It's going to be the minimum of y, and that has to be the second set of coordinates. So let me move one of these 0, 0s. I'm going to cut and paste. Feel free to pause the video at any time if you get behind. And that's going to give me, let me get rid of, oh, I need the comma, dot, dot, dot. All right, so by moving the values into the y position, that should give me a y-axis. So let's see what happens. And sure enough, it looks like we do have a y-axis. Okay, here's the problem. I want to go from the maximum. Oh, I actually want to do this. I want to go the maximum of the absolute value of y. Don't always assume that the maximum y is positive. Okay, and I want this to be negative maximum of absolute, ABS's absolute value of y. Okay. So if I do this, let's see if that worked. Yes, so you can see in order to get the y-axis to go from one end to the other, I wanted to go to the maximum of y, and just because y might end up being negative, in that case, you'd want the minimum of y. But if we do the maximum of the absolute value of y, we'll get how large y gets. Okay, and then if we go from the negative of that to the positive of that, that will give us a nice y-axis. Okay, now it turns out the x-axis, or the z-axis, we don't have z values. So I'm going to use the same thing that I have for y, except move it, Control copy. Okay, and then I'm going to paste it. And I'm going to put another set of zeros. I'm going to move these zeros from the z position, cut them, and put them in front. Okay, and so now you can see that the command I had for y is in the z position. So if I run that, now I have an x, a y, and a z axis. All right, so it looks something like this. All right. Now in 3D, there are some other little tricks that I can put in here. Okay. let's first of all see what we can get rid of. Okay, we can get rid of these commands right here. We're not going to use those. I'm pretty happy with the way this is looking right now. So we can get rid of those. We can get rid of the grid on. We're not going to have that in the middle of everything. But there are a couple of other tricks I'm going to add so that we can see this. Oh, we have the surface area printing nicely up there at the top. Okay, a couple of other little tricks that I want to add are, first of all, I'd like to be able to see the x-axis in the middle of all of this. So I wish that this shape was a little more transparent. Okay, if it had a little transparency to it, I could also see what's happening kind of on the inside a little bit. So in the surface command, there's a way to create transparency. Just like we have a line width property in this plot statement that is assigned to be a value of 2, that makes the black line doubly thick. We have a property called face alpha. Okay, the faces are the little panels, and face alpha will determine how transparent the panel is. Okay, if you say 0, it'll be completely transparent. Let's put that at 0.5. So you can see it's highly transparent now. In fact, I would argue that it's too transparent. Okay, it's a little muddled to see what it looks like. So if I want it to be completely opaque, I would make this a 1. So let's make it more opaque and make that a 0.8. We can now see through it a little bit, but you know, I might want to make it be able to see through it a little bit more. So I'm going to call that a 0.7. And I'll go with a, I don't know, maybe I kind of like the 0.8. Okay, so we'll go with a 0.8. So it's a little bit see-through, but it's mostly opaque and a little bit transparent. 1 would be perfectly opaque. 0 would be perfectly transparent. So I'm making it sort of 80% opaque where you can't see through it. Now, the other thing is which I don't really like having X here and Y there, and I do like Z there. So what we're going to do is we're going to rotate what's called the view. All right, so the axes are equal. We could put this view anywhere after the plot statement, but let's do it after this. Okay, and we're going to type in, so for the view, let me see what I picked here that looks nice. We're going to rotate this a little bit. I'm going to put in 45, 20, and let's see what that does for us. Okay, so at a 45-degree angle, you can see that the X and Y's are kind of, it's rotated now where X is in the front, okay, and Y is going over this way, okay. And so I like that 45-degree rotation, although I probably won't rotate quite that far. Let's see what happens if we change the 45. Let's just make that a 30. You'll see it's a little bit more sideways, and I really do want to be able to see that fairly sideways. I'm going to make that a 20 because we want to kind of be able to see what the line originally looked like that's being rotated. So I'm going to go down to 20. Okay, this first number is called the azimuthal angle. You don't need to spell azimuthal, but it's how much the XY plane is rotated. So we're moving our viewing angle of the camera 20 degrees off of the x-axis. If I made that 0, right, we're actually looking at this. Oh, here's the x-axis. The y-axis is actually pointing directly at us. So if I rotate it around by 20, we're not looking head on the y-axis. The y-axis has been rotated. This line right here is the y-axis. It's been rotated 20 degrees around. So we're kind of looking at it from an angle. Now, this is called the polar angle. It's kind of how far you are off of the XY plane. So that's 20 right now. It means our camera has been elevated 20 degrees above the XY plane. If I made that 40, your camera is higher up, so you're looking down closer to above. If I make that 60, the camera angle switches up to being even higher. I really don't want the camera to be far off of the XY plane, so I'm going to lower that to 10 degrees. Okay, and that gives me a nice picture here. Okay, and a final thing that I'm going to do, when I come over to the picture, I want to be able to rotate it around. So I am going to turn something called rotate 3D is going to be turned on. So when I run this, I can then just go right over to the graph and rotate it around to look at it. Okay, and if I click over here, you can see the surface area calculation is right there on the top of the graph. Okay, now that's for 4 subintervals. If I want to do it for more subintervals, I could do this easily for, let's say, 40, and I'll get a more accurate answer. Okay, you can see how the dividing lines have cut down and the curve is much smoother now. That's closer to the actual surface area of that shape. But you can see it actually didn't change by much. If you look at the number on the title right now, it's around 105.1229. If I only go down to 4, it's still 105 point something, okay? It turns out it's a little bit large because of the way those secant lines cut across the curve and then rotate around. They're actually outside of the curve. As I go up to higher numbers like 40, the surface area drops a little bit, but not by much at all. So going 4 subintervals gave me a pretty good answer. 40 subintervals is going to give me a spectacular answer. If I go to 400, our surface is just going to look black because the lines are so close together. It's actually hard to see the surface mesh because there are just so many lines. So 40 gives me a very accurate answer while still being able to see the shape nicely. All right, it looks kind of like a lampshade on its side. So if I wanted to design that and know how much fabric would be needed to make this lampshade, I could give the equation of the line and use this rotation method in order to calculate what the surface area is.